everybody, another splendid day here in the shop. Been tying up a lot of loose ends this week. Had a little bit of vacation time at work, so I took off part of the week. Right about the same time, the wife hit me up that she was taking the kids this weekend to her mother's. So I've pretty much had free reign of the ranch since Thursday and Friday. So I've got a lot of loose ends buttoned up. I got the power supply going. I got my motor spinning with Linux CNC. I still need to get into that to figure out exactly how I'm going to work that with the two motors. I know that you can drive the two Y motors independently, which I plan to do. For now, I've just got it wired up so that they both move simultaneously. So I'll get that figured out sometime tonight, tomorrow, this week, somewhere in there. But today, specifically, we're going to build out our Z platform. A couple of ways that you can go about doing that. I've actually set out to build it. This is, I think, the third time. Every time I get ready to build it or I cut out some plates, somebody posts on the Discord or the Wiki or one of the other places, hey, here's this new Z-axis that I just came up with. So right about the time I was getting ready to start my last Z build is when Hogs and I think Logan and some other guys posted the new V3. So that's what I'm going to build. Be a few things different with my build because that's what I do. I'm going to go ahead and apologize right out of the gate. If you hear a lot of animal noise in the background, I do live on a farm. I have goats, chickens, turkeys, ducks. We've had an American bald eagle who has been visiting the ranch in the evenings. The ducks, chickens, and turkeys do not like bald eagles, and they will let me know that they're out there. Normally the ducks will see them first and they'll start squawking, and then the turkeys will join in. So if you hear a bunch of ruckus outside of my shop, there's nothing I can do about it. Bald eagles are kind of rare here in South Mississippi. They're not rare to me. I used to live in Alaska and they were like seagulls up there. But nonetheless, if you hear a bunch of racket out there, no one's getting, well, someone may be getting murdered, but it's one of the farm animals seeing that bald eagle flying around. It's pretty cool here in the South, not something that we see a lot. I'm sure that he's hunting whatever will slow down long enough for him or her. I think it's actually a female because it's pretty big to catch. So with that said, let me get the camera repositioned and I'll show you what we got going on. So there are a couple of options that you can do with your Z plate. And I'm doing the easiest one first. And that is I have cut a Z plate out of 1/2" MDF. This template is available on the wiki. If you download the full Fusion file, this is included in that. I just used Fusion to process the G code. You could also print out a template of this and you could drill it without a CNC. Now I do have the mostly printed CNC. I figured before I decommission it, I would get as much work out of it as I possibly could. I'm fully comfortable cutting the MDF with the mostly printed CNC. I'm not comfortable cutting aluminum at this point. It'll probably do it, but I just don't want to risk it. So I figured I would show you guys how I did this and kind of the changes that I made. So we've got the Z plate. We've got the spacers. I believe that these are 7mm spacers, also available in the PrintNC Fusion file. 250mm linear rails with the wide slides. Bearing blocks, I guess they are technically called. I've got my spindle mount. I've got one of the 4-hole types, which does require a backing plate. This backing plate, I did not make this. I bought this spindle secondhand off of a Discord member, and this was included in the box. It works, so I'm going to use it. Various hardware. Ball screw. This is a this is a 1204 ball screw, meaning it's 12 millimeter diameter, 4 millimeter pitch. This is the printed riser that is available. This is the printed motor mount that is also available in the Fusion file. I've got a BK10 with the screw. I've got all my assorted hardware and my tools, so this should be ready to go. Now, once I get my PrintNC finished, I do already have some aluminum. This is 6061 aluminum that I plan on making a Z plate out of, but I have seen guys on the interwebs using MDF just fine. I did try to go ahead and route out, see if I can find it, the exact replica of the aluminum plate that I'm going to use. I did do that, but these holes ended up being a little thin with the MDF because you're boring down here for the trough, I think 2 millimeters, and you go down another 5 or 6 millimeter for your screw hole. That only leaves about 4 or 5 millimeters of split MDF in there to grab a hold of, and I just didn't feel comfortable with that. So the 1/2 inch in their 12 millimeter MDF will hold just fine. One thing that I did different, I think the initial plan or design or idea with the MDF was to use wood screws to hold your linear rails in. I was not comfortable with that, and what I did is I went to the hardware store and I got some of these T-nuts. Those are number 10 T-nuts. They're 7/16 inch long, so they go almost all the way through. And I just thought that would be a better plan. I did take a Forstner bit and make a little shallow depression to hold each one of those so that the back would still be flush. For the $2 of additional costs, or $3 for the 4 T-nuts and associated bolts, I thought machine screws, I thought it was a great deal. So again, drill those out, knock them in with a hammer, good to go. First thing we want to do is go ahead and get our printed riser attached to our ball screw. To do that, you line it up and you take and put some M4s, if I can get them lined up just right. Like so. I do think that this right here is probably the Achilles heel of my setup. The entire weight of the Z-axis is hanging off of this connection right here. Probably not a problem, but if I think anything on this Z build was going to fail, it would be these M4 bolts pulling out of that plastic. I could see that possibly happening. I don't know the likelihood of that happening, but this will be the first thing that I upgrade whenever I get my PrintNC finished. So kind of set your riser there in the middle, put your spacers on, eyeball that. Get a couple of bolts in there just to kind of hold it down. Don't try to get too crazy and torque all of these down yet, because you need to wait on that. So your riser should kind of snap in between there. Now we're going to do our other side. Same way. Couple of bolts to hold everything together. Again, nothing tight, just to hold it. Carefully slide these down to get your two under your bearing blocks. What you don't want to do is you don't want to slide this bearing block all the way off the end of these rails. Otherwise you're going to be picking up ball bearings for days, maybe weeks, months, years. So again, I'm just finger tightening, so to speak, these. There's still some slop in there. You still move it around. So what I want to do is I want to start down here at the bottom, and I'm going to get those bearing blocks. Actually, before I go there, check that. I want to go ahead and put what would be the tram plate on the bearing blocks. Now there is a threaded hole in this riser, and if your setup allows, you can put, I think it's an M5 bolt through there to hold that riser to your tram plate. I'm not going to do that. I think that riser will hold in there just fine without any additional help. That may come back to bite me in the butt, but all right. So get these snugged down. And that's going to hold everything square. So once you get that, start tightening your linear rails. I like to go all the way to the bottom, all the way to the top, and then use your setup here to hold everything parallel. So once you get the top done, you can go back and catch these ones in the middle. Again, you don't have to overly torque those, but one ugga-dugga will work. We are almost there. Again, be careful when you're moving this around that you don't slide your bearing blocks off and you don't take your ball nut off of your ball screw. Now, the BK10 and the associated motor mount are going to mount right here. Of course, I do things a little bit different. This has 4 holes for M6s that will go through the motor mount, through the BK10, and into the Z plate. The problem that I had is I did not have any M6s that were long enough to go all the way through the Z plate and put a nut on the back. So to improvise that, I used some smaller M5s, which you could have used M6s. I just didn't have any M6s long enough to go through there, and I don't think I have any M6 nuts handy. So I just put a couple of M5s through and just run a washer and a nut on the back. Again, finger tight those nuts, and then you can put your motor mount and run screw. So I did opposite corners with the M5s on the BK, and I'm doing opposite corners with the M6s through the motor mount and the BK. These will actually go through, and they have threaded themselves into the 5mm holes in the wood or in the MDF. Now I would not trust those self-tapped or self-tapped holes in that MDF to hold any of this together, which is why I went with the M5s all the way through with the nuts on the back. I think that these will hold the motor mount just fine, but I would not trust them to support the whole weight of the Z-axis. Again, tighten those down half a ugga-dugga. Probably should have put my ball screw retaining nut on before I tightened all this down. Loosen it back up just a touch and see if we can get it to go in there. Little trick to get that nut in there if you run your ball nut all the way up to the BK. But I can tell you there's a lot of give in there. So tighten it down. Go ahead and run your set screw in. And we are well on our way. Now once you get all that done, you can go ahead and torque these back down. And now we are cooking with gas. Now with mine, you can go ahead and torque these M5s down, and I'm just going through the motor mount screw holes onto those. And I think that's plenty strong enough to hold everything for now. It may make a liar out of me. So for the most part, we are pretty much done, short of mounting this to our gantry. Again, there are different versions of spindle mounts. This one was with the spindle that I bought off the other Discord member. It's a little different in that the mounting bolts also tighten down the spindle mount, so you do not want to torque these down just yet. Now, you could go ahead and mount your spindle in here. Well, no, because we still got to get to the back. But I would not want to hold this dude up while I'm trying to mount my spindle. I will tell you just a word of caution that you can back drive these ball screws. So you need to be extra careful. And what I'm doing is I'm just going to go ahead and loop a piece of wire over here up through my motor mount and just give it a couple of twists. Now that will be enough to hold this, but once you get that spindle on there, this thing is pretty spindle is pretty heavy, and it is heavy enough that it will backdrive that ball screw and cause you all sorts of problems. So you don't want to do that. So put a tie strap, put a piece of wire, put something in there so that this whole shooting match doesn't fall apart while you are trying to mount it to your gantry. So I'm going to go ahead and get repositioned. We'll set you up over there and we will mount this, and we'll call this a day. All right, so we've got the completed Z assembly. Now we need to mount it to our gantry. And don't mind these rollers. They are long. They were cut for the first iteration of the Z. So I'm gonna, once I get everything done, I will go ahead and chop these off so that they're not overhanging. But for now, this will work. I have enough real estate that I don't need to worry about the 1 inch of travel that I'm going to lose by leaving these small or these large rollers on this Z plate. You can go ahead and do a clamp on here if you want. I don't think that's entirely necessary. Again, I'm using 20mm M6s to hold this on there. I'm doing this kind of backwards with the way I'm holding it. Get them in there kind of where they should be. Again, do not torque these down because you're going to need to make some adjustments. I'm going to line my top holes up. Sorry if I'm getting in your way. I'm right-handed. I obviously can't use this T-driver with my left hand. So again, everything's loose. At this point, you also want your rollers and your L bracket on the bottom to be loose enough that things don't flop around too much, but are tight enough that things don't flop around, but loose enough that you can still tweak and adjust everything. So once you've got everything on there, go ahead and move your Z-axis back and forth. Make sure that it moves smoothly end to end and that you're not binding anything up. Once you do that, you can start tweaking everything down. Again, start with your face plate. That's going to clamp down to your rollers. Remember that you're going into MDF here, so you don't want to get too torquey with these, but tight enough that it holds everything. Once you get those all tightened down, and I'm just doing 2 on the top just for demonstration's sake. Once you get those done and you verify everything still goes, start torquing your rollers down. And do your angle plate as well. At this point, both your linear rails on your gantry are, again, just tightened down enough to hold it. Nothing's torqued down. Because you want to make sure that you get everything rolled. So once you get that, go ahead and verify that everything still goes smoothly without binding. Go to your end and start torquing down a few of these bolts. That one's torqued. That one's torqued. Go to the middle of your gantry, do the same thing. And then to the far end of your gantry. Helps if you don't use your waste board for a workbench while you're building it, but you're going to, just like I did. And then go to the end and make sure that everything still rolls without binding up, which I'm good here. The last thing we want to do is mount our spindle. Like I said earlier, make sure that you have a wire of some sort or a tie strap, something to keep that from back feeding all the way down. I'm going to do this plate here just as an extra level of oh crap with my single piece mount. You will have to pry it open just a little bit. Some of the different spindle holders have a little bit different setup. And I want this to go in about the middle. So about the middle, and what that will do is that will let you go all the way down and touch the nose of this to the base, or to the to the waste board. There we go. Which is plenty deep enough. That would also allow you, if you were to set up a removable waste board over here where you wanted to cut, say, dovetails or finger joints, you could do that as well. So about midway, and then I'm going to tighten this down just enough to hold that in, but not torquing it down just yet, because I want to get this somewhat square to my table. And to do that, I'm going to use one of these Wixie angle gauges. And I'm just going right onto my wasteboard support here, my wire rail support, whatever you want to call this. I'm going to zero it out. And then I'm going to check it. Actually, I can check it right on my spindle. And I'm at 90.2, so I know I need to tweak my spindle this way just a touch. Let's see if that was enough. .1. A little too far. And we're within 1/10 of a degree. I don't know if you can see that or not. So there we go. We are at 90 degrees to my frame. Still at 0. This has a little bit of fore and aft component in it, but it is 90 degrees. So that's a good, quick, dirty way to get your spindle set, at least initially. If you're wondering why I'm only using 3 bolts to hold this spindle in, because the gentleman that I bought this off of had the exact same problem that I did, snapped one of these little cheap combo drill tap off in where the 4th hole should be, but that's plenty good enough. I chuckled whenever I saw that. Whenever I took it out of the box, I said, hey, there's something in that bolt hole right there. What? Oh, that's a tap. I think right here is where I broke one of the first tap whenever I was drilling out with the M5. Those things are very, so what I did, I didn't have any M6s long enough, so I tapped those out to 1/4 20, which are common. I have boxes of them around the shop in every length you can imagine. So that's that. So my spindle is in, Z is mounted, everything operates fine. Those bearings are a little noisy, but they're not binding up. I think that's just the cheapness of them. I have not put any grease in them. As a matter of fact, they don't even have Zerk fittings on them yet. So whenever I disassemble everything, get this painted, and get it going, I will do that. But I'm going to show you, maybe you can see this. I'm manually spinning this ball screw. But I just wanted to show you why I put that wire on there. So that spindle is enough that it will pull itself down and back drive that ball screw. So you don't want this sitting which is one of the reasons why I want this nose to go all the way down and touch the wasteboard. So if anything crazy were to happen and this thing decides to go down by itself, that's why I've got this wire on there. Now that wire is enough to hold it, I'm gambling on, and if not, I'm going to leave something under it so that it can't come all the way off and mess up my bearing blocks. So there's the Z plate, or the Z axis in a nutshell. Hopefully I can edit this down and it won't be too long and boring. Most of my videos do tend to be long and boring, so go with it. I guess next up we will get the gantry ball screw remounted, get the motors on, and we'll go from there. So I'm probably going to go in and try to figure out how to get my Linux, how my hardware acceleration layer, assembly layers, whatever those are, on Linux CNC lined up. So probably the next video I will have some motion going on, and we will call this complete, at least enough to, I'll probably do a practice cut. I have not set up my spindle or anything. I have not built the table that this thing will reside on, which will be on that corner of the shop. But again, my plan is to get everything set up, kind of get it dialed in enough that I can run it and say, yeah, it's a CNC, it's cutting. Still have to set up my VFD, my spindle controller, have to get the Linux CNC set up. I will make some cuts, and then I'm going to tear everything back down, paint all my steel. Again, this was just primer that I put on here, to one, to keep it from rusting, because South Mississippi. But I like this primer because I can mark on it and I can see where I made a mark. Whereas with raw steel, you can mark on it, but it's not as easy. Actually, you can mark on this with a pencil or finger smudges, as you can see here. But this is it. This is about as, other than my ball screw wanting to move up and down, this is pretty, and I'm putting some oomph into that, and it's not moving, or at least not moving anything appreciatively. I know with mostly printed CNC, if I did that, something would break. There's really nothing with this setup that's 3D, even though it's called the PrintNC CNC. Really, there is nothing that is that the rigidity of this machine is dependent on that's 3D printed. Now right now these rails or these rail spacers are in there. The roller face plates are 3D printed. That's really about the only thing that right now, as this machine sets, that's not a metal on metal contact. Most of your 3D printed stuff is just spacers and standoffs. So let me get this wrapped up. I will go in tonight, try to get this video edited down to something usable, and hopefully maybe tomorrow we can do another one. So that'll wrap us up for today. There you go. Have a good one.